Hello, this is Mrs. Boots, and welcome back. This is the second part of our notes for transformations of parent functions. With this one, we have a table with all of the equations in it, and each equation has one thing that's changed, with the exception of the last one. The last one, we just changed everything. We threw it all in there to see if we could figure it out. Okay, so there's two ways we can do this. One, you could just watch me do it, which is fine. It's a video. That's cool. Or two, you could do it yourself. You could actually cut off the video, figure it out, and then check yourself. So with each equation, you're plugging it into y equals on your graphing calculator. Then you're going to hit the graph and look. Now that was the x squared plus 3. That's the very first one. And if you'll notice that x squared plus 3, what did it do? It moved up, right? So if I add 3 is going to move up, what do you think subtracting 5 is going to do? The opposite, right? It's going to move down. Now notice both of these are outside, okay? So write yourself a little note. This is outside. It's at the end. It's being added or subtracted, okay? You're either adding or subtracting on the outside. So now let's look at the second one. So what we're going to do is the second one we've already done. Let's look at the third one. So we have y1 is negative x squared, okay? So negative x squared, let's look at our graph. What did it do? It reflected it. We really weren't surprised by that because we just did an example of that from the graphs. So this is a reflection. Now where is that negative at? It's being multiplied out front. So write yourself a little note. This is a multiply in front. Okay? Now we also saw these on the graph. The 5, a really big number, right? What is that going to do when it's multiplying it? That means it's going to get 5 times as big. Well, if I'm 5 times as big, yeah, that's a stretch. Okay? So make yourself a note. Stretch, that's a whole number. And again, it's in front. It's multiplying. So if the whole number stretches it, what do you think the fraction is going to do? Because we saw one of those. You're right. It's going to compress it, okay? So it's going to make it get y. It's going to compress it. Remember, it squishes it down and everything comes out the side. It is a fraction. It's actually technically a number in between 0 and 1. So it could be a decimal, right? 0.5 is the same thing as 1/2, which basically means it gets half as tall, so I'm squishing everything down. It is also in front. Okay? So now let's look. We can do a quick example. So we have x plus 4 squared. So we're going to plug that into our y1. Let's see what happens when we add 4 inside. Notice it's inside with the parentheses. It's not on the outside. Oh, check it out. Wait a minute. It moved to the left. But we're adding 4. Okay. This is where parent functions just totally trip you out. I always used to say it's like a spy on the inside. He's always going to lie. So the spy lied. Okay? It's Texas drawl there. Right? So the spy is lying to you. He's not going to the right. He's going to the left. He's going to try and fake you out. But notice where that 4 is. It's inside parentheses with the x. So we write a little note to ourselves in that last column. It's inside with x. Okay? It's being adding or subtracting with that x. So if positive 4 moved it to the left, what do you think the negative 7 is going to do? The opposite, right? It's going to move it to the right. Okay? This is also inside with x. Okay? So if it's outside being added or subtracted, it moves it up or down. If it's outside being multiplied in the front, it's going to reflect it, stretch it, or compress it. If it's inside being added or subtracted, it's moving it left or right. So we have, based on where the number is located, how does it affect our parent function? So now let's look at the last one. We got three things going on here, right? We got that 1/2 in front. That 1/2, we've already said, is a compress. So the first thing it's going to do is compress. That's our 1/2. Okay? Then I've got my +3. Now positive, he's on the inside with x. Anything on the inside with x is lying to you. So do the opposite of what it says. So we're going to move left 3. And then I have the 2 at the end. You got it? It's outside. It's being added. He doesn't lie to us. We're going to move up 2. So we compress by 1/2. We move left 3. We moved up 2. Now what was the parent function? Yeah, that's what the square tells us. The square tells us this is a quadratic. And based on that information, we can now graph our parent function. And we'll do a couple of examples like that. First, I would like to give you the format for the parent function so that you understand how these are put together. Okay, they're super easy. And you'll see a pattern here, right? Linear. Let me change markers. We're going to write this in terms so that all the letters match. So my A in front does what? Yeah, that's my reflection, stretch, or compress. Basically, that's my slope. My K at the end represents up or down. That's where we're moving it up or down, okay? So let's just write in each one of our parent functions. So I have a y equals, and this is going to be an x squared. Absolute value, y equals absolute value of x. Square root of x. Cubic, super easy. Cube of x. Cube root. Okay. Rationals are a little bit more tricky. We know it's divided by x. Okay. Exponential. I'm just going to use a 2. And then we have our log function. Log, I think, is the easiest one. Okay. So with each one of these, we can put a number out front multiplying that is going to stretch, compress, or reflect it. Okay, now notice with the rational, it just flips up and it's on top. But the rest of them, it's all clearly out front. Okay? I can also put in my left and right. Now left and right goes inside. We call that H for horizontal. And we put it in there as a negative. And the reason we list it as a negative is because he's the spy. And he's lying to us. So we list him as a negative so we know we're going to do the opposite of whatever he said to do. Okay? So notice with the rational, that left and right is actually in the denominator with the x minus h. Okay? And with the exponential, it's in the exponent with the x. Okay? Now we can do our up and down. Up and down is added at the outside. Guess what we're going to do? We're going to add it to the outside. It's outside the square root, outside the cube, outside the cube root. I missed one. I know, you should have said something, right? You probably did, and I just didn't hear you. Every single time. Rational, look, it's outside of that fraction. Exponential, it's outside the exponent. Log, it's outside the log, okay? So, if it's outside at the end, that's my K. It's always going to move it up or down. If it's in front, being multiplied, it's going to reflect, stretch, or compress. And if it's inside with the x being added or subtracted, that's my H. That's my horizontal shift, left and right. Remember, with the horizontal, positive goes left, negative goes right. we have a few examples that we will do in the last notes video, and then you will be free to start your practice. I hope this helps. Welcome back. This is Mrs. Boots, and we're going to do 4 examples on our transformations for parent functions. This is easy, and it's very consistent. We do the same thing every time. Okay, so first thing we're going to do is identify what each number means. So I notice on example 1, I have a 1/2 in front. What is that 1/2 going to do? Right. That 1/2 is going to compress or make my function wider. So it's going to flatten it a little bit. Then I have a 2 on the inside. It's a positive 2. So what is the positive 2 on the inside going to do? That is correct. It's the spy that lies. So it's going to move us to the left 2 instead of to the right 2. All right. The -5 at the end. Number added or subtracted at the end is going to move us up or down. Negative means it's going to go down. So we're going to go down 5. Now, what kind of function is this? You got it. This is an absolute value, okay? We know it's an absolute value because these wonderful vertical bars. So we know the shape of our graph is the V shape. So now we're going to come in and we are going to graph our function. Super easy. Okay, we moved it left 2. 1, 2. We moved it down 5. 1, 2, 3, 4, 5. Boom. That is where the point of my V is at. Now, my V is still facing up? Yes, it is, because we did not flip it, but we compressed it. So instead of going over 1 and up 2, or I should say up 1 and over 1, we're going to go up 1 and over 2, okay? So I'm going to go up 1 over 2, up 1 over 2. So my V is going to be wider because it's compressed. All right? You only need 3 points, 3 distinct points. I mean, we could do more points if we wanted to, but we don't have to. Let's go ahead and do our domain and range so we remember how to do that. Absolute value, domain and range, it's going all the way to the left, all the way to the right. So we're going to go negative infinity, positive infinity. My range, okay? How low does it go? Well, all the way down to that -5. And how high does it go? It goes to infinity. Buzz Lightyear, to infinity and beyond. Now, is the -5 included? Yes, it is. It's right on my curve, so it gets a nice pretty square bracket. Okay? Let's look at example 2. Example 2, first thing, what do my numbers mean? Well, I got this pesky 2, right? What is he doing? He's multiplying. We can think of it as a multiply out front, just like our 1/2. It's a 2, it's a whole number, so that means he's stretching us. He's going to make our graph nice and tall and skinny. Now that 4 underneath, what is the 4 doing? He's lying to us. He's right there with the X, so he's going to do the opposite of what he says. It's a negative, so we're going to go opposite to the right. We're going to do the positive. Okay, now let's look at that 7. The 7 at the end. Yep, it's adding or subtracting at the end, so it's going to go up 7. All right? So now we can create our picture from these pieces. Oh, what kind of function is this? Fractional, rational. It's got the 2 parts, right? It goes high, goes low, doesn't meet in the middle. So we went right and up, so I'm going to draw my graph a little off so that we can see that we went right and up. So we're going right 4, 1, 2, 3, 4, up 7, 1, 2, 3, 4, 5, 6, 7. Now with rational, that is where the asymptotes are at. So think of this as your new X and Y axis. Okay, these are our new X and Y axis. So I'm going to put a little 4 down here, put a 7 up here so we remember where those are at. Okay, well now we would actually draw our curve. The rationals are kind of weird, and it's hard to see the stretch or compress because you would go over 1, up 1 to get your starting points, and down 1. So I got them diagonal from each other, and then they're just going to get really close really fast. And if you plug it into the calculator, you can see just how fast those numbers grow or shrink. Okay? For the purposes of this curve, that's all you need to do right now. We will do much more to it in a few more units. All right, let's look at example 3. What is going on with this example? What is this function? It's an exponential. We know that because x is in the exponent. So we know we have an exponential function, right? But we have something in front. What in the world is that thing going to do? You got it. It's negative, so it turned our smile upside down into a frowny face. We have a reflection here. I see a +1 up there with my exponent. It's with the x. Remember, anything with the x is the liar. He's the spy. He's going to do the opposite. So instead of going to the right one, he's going to go to the left. And then my -3 at the end, yeah, you got that one. That's the easy one. Down 3. Okay, let's draw the graph. We forgot to do domain and range on example 2. Don't stress, we'll go back. We'll do that when we do domain and range on example 3. Okay, so I'm going to draw my graph. Which way did we go? We went left 1, down 3. 1, 2, 3. Boom. Okay. So now I got to remember what my exponential looks like, right? It kind of goes up and to the right, but this point's actually not on the curve. That point represents my asymptote. So instead of going up and to the right, guess what? Reflection. So it's flipped upside down. So I'm going to go one more down instead of up, and it's going to do something like that. Now that is not asymptotic to the axis. It's going to keep going out, remember? It's going to keep going. So my domain for my exponential is -∞ to +∞. And what's my range? Yeah, it stops at that 3. At that -3, it's going to stop, okay? So we're down below it, so we got -∞ all the way to -3. But do we include the -3? No, -3 is an asymptote, so it gets a parenthesis. Okay, let's go back and do domain and range on example 2. Okay, so remember our domain goes all the way to -∞. This arrow is going to keep it going. It's going to come over to that asymptote, which is at 4. It's going to go around the 4 and then keep going all the way to +∞. So remember how I said earlier, whatever numbers you see in your equation, you'll see them in your domain and range. We saw the 4 in our equation. He moved us to the right. We see the 4 in our domain. Okay, so anything that I see as a horizontal left or right, I should see it in my domain, unless it's infinity to infinity, right? If it's got infinity, it's going to have everything. Otherwise, I will see it in my domain. So in my range, what number would I expect to see? My 7, whatever moved it up or down. The 3 moved it down, he came into the range. The 5 moved it down, and he came into the range. My 7 moved it up, it's going to be in the range. So we go from -∞, because that arrow is going all the way down, where curve goes up, hits our 7, but never touches it, okay? And then it goes around it, that's our U shape, we tunnel underneath. And then we keep going up to +∞, okay? That would be the first 3 examples. Now let's look at example 4. This one's kind of weird. Not really. We told you some stuff, and now you get to write the equation and do the graph. Oh my goodness, I know. It's craziness. All right, so let's look at it. First thing you always write is y equals You can do f of x equals if you want to be fancy, and that's fine. Either one, okay? So we moved it up 5 and right 3. What is my function? It's log. So I'm going to write the word log because it's a log. Now, the log has to be of x. What goes inside with the x? Is it going to be the 3 or the 5? Yeah, left and right goes inside, which is the 3. Now, is he adding or subtracting? Remember, the guy on the inside, your spy, he's going to lie to you. So we're going to get a negative, which means my 5 is outside, and he's going to do exactly what he told us he's going to do. So he's going to do the 5, okay? So now let's put that on a graph so we know what it looks like. Log is very, very similar to exponentials, okay? So we're going to move right 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. Okay, so we got a little dot there. The problem is that 3, remember for the log, is a vertical asymptote. So our curve is actually not going to touch that. Okay, we're going to go 1 to the right of that curve. And that's where my log goes through. So my log is going to come down. It's not going to touch that line. And then it's going to go up and out. All right? So with the log, we have the exact opposite on our domain and range from the exponent. Because remember, they're inverses of each other. So my domain starts at the 3 and goes to positive infinity. Do we include the 3? No. It's an asymptote. It gets a parenthesis. It's never going to touch it. It's going to get to 2.9999999 and never touch that 3. Okay? Let's do the range. How low does it go? It's got an arrow, so it's just going to keep going. How high does it go? It has an arrow. It's going to keep going. So my range goes from negative infinity to positive infinity. All right? This concludes our 4 examples for transformations of parent functions. Please go ahead and start your practice problems now.